So this is section 10.2, and basically what we're doing for this section is simplifying. So let's simplify square root 72. To do that, we have to prime factor 72. So you have the you know how to do this. I'm just going to skip over it. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. And then you look through the factors and figure out if there's any perfect squares. So we have this, we have 2 times 2, which is 4, which is a perfect square, and 3 times 3, which is 9, which is a perfect square. So we can multiply those together to get 36, and what we have left is 2. So 36 is a perfect square. And then to take out 36, we basically just have to divide by, so we have to square root 36, which is 6, and then we can bring it out. So we have 6 times root 2, or 6 root 2, and that's your final answer for this right here. For the next one, we have the answer for this one, 6 root 2. So we know we have a 6 on the outside and 2 on the inside, but then we have all these variables. So square root x to the third is not like, it's x to the third is not a perfect square, but we can take out x squared and then leave x inside. So the square root x to the third equals x root x. Since we're taking out x squared, then we square root that and put it on the outside, so x root x. So, and then y squared is obviously a perfect square, it's y, so we can take that out. And z to the fourth is a perfect square as well. It's the square of z squared, so z squared is z to the fourth. What we have for the final thing is we have an x on the outside, so 6x, y, and z squared. And then on the inside, we have the 2 from earlier, and then we have that extra x that couldn't come outside. And that's how you that's how you simplify this. Okay, so with radicals, there's a rule that there cannot be a fraction inside the radical, and there also cannot be a fraction in the, there cannot be a radical in the denominator. So we can do, so from here we can bring it to this, and then to simplify this further, we have to multiply by this, and this will get rid of the square root 3 in the denominator, and square root 5 times square root 3 is square root 15. So square root 15 over 3, and that's your final answer for square root 5 over 3. And for this last one, this may look a little bit more complicated because it is, but for this one, we have to use difference of squares. So difference of squares is a minus b times a plus b. So we have to multiply by the conjugate, or that means just switch the sign of the radical. So 6 plus square root 2 over 6 plus square root 2. And then, so let's do the bottom first. So since we're doing difference of squares, that means that it'll be 36 minus 2. And then on the top, we have 4 times 6, which is 24, and then 4 root 2. So 24 plus 4 root 2 over 36 minus 2, or 34. And then we can simplify further by dividing by 2. So we have 12 plus 2 root 2 over 17, and that is your final answer. So that was section 10.2. Now let's move on to section 10.3.